Hello students, once again welcome to Bholanathacademy. In this video students, we are going to see the preparation of aldehydes and ketone. Okay students, the first reactant which we are going to use to prepare aldehyde and ketones, here I have written. So here students, first reactant, or you can say first raw material from where we are going to prepare aldehyde and ketones, I have written here. So first is from alcohols. If alcohol is given, then how you are going to convert alcohol into aldehyde and ketones. From hydrocarbons are given, that is raw material, or you can say reactant is made up of hydrogen and carbon. From acyl chloride, acid chloride is given, then how acid chloride you are going to convert into aldehyde and ketones. And from nitriles and from ester. Okay students, so these are the raw material from where we are going to convert into aldehyde and ketones. Okay students, so students, in from alcohols, students, alcohols are also first degree alcohols, second degree alcohols and third degree alcohols. We are going to use alcohols first degree, second degree, and we are going to prepare aldehyde and ketones. From hydrocarbons, acyl chloride, from nitriles and from ester. From alcohols students, by oxidation of alcohols, you have alcohol students, you are going to oxidize the alcohol, you will get aldehyde and ketones. Okay students, here we are going to use first degree alcohol first. Okay students, say for example students, first degree alcohol is, here I am going to take, that is ethanol, CH3, CH2 and OH. Okay students, here the hydroxyl group is attached to first degree carbon, so it is first degree alcohol. Okay students, OH is attached to the first degree carbon, so it is called as primary alcohol, or you can say first degree alcohol. Example is ethanol, or you can say ethyl alcohol. Okay students, now you will oxidize. Via oxidation of alcohol, so you have to use nascent oxygen. How you are getting this nascent oxygen students? If you, the mixture of K2Cr2O7 and sulfuric acid will gives you nascent oxygen. So what happens students? Because of this, there is a elimination of hydrogen molecule from alcohols. Hydrogen atom will be removed as a water. So removal of hydrogen from the reactant is also called as oxidation. So with the help of oxygen, we are going to remove the hydrogen from ethanol as a water. So it is called as oxidation. So what is the remaining students? So you will get CH3, one hydrogen from here and one hydrogen from here. So that is why you are getting H2O. Now the compound you will obtain, that is called as CHO. This is aldehyde. So from first degree alcohol you can prepare aldehyde, that is called as ethanol. That is called as So ethanol is converted into ethanol. Okay students, ethyl alcohol is converted into acetaldehyde. You can also call as common name. This is ethyl alcohol, which you have converted into acetaldehyde. So ethyl alcohol you have converted into acetaldehyde by oxidation method. In second example students, if you are taking propanol, CH3, CH, and this is CH3. Now hydroxyl group is attached to second degree carbon, so it is called as secondary alcohol students. So example is, well famous example is 2-propanol. This is nothing but what? 2-propanol. This is the IBC name students, or you can say isopropyl alcohol, which is attached to this carbon, so it is also called as isopropyl alcohol. Okay students, now we are oxidizing with oxygen. How you are getting this oxygen, nascent oxygen students? By the addition of K2Cr2O7 and sulfuric acid. These mixtures will gives you nascent oxygen. What happens students? This nascent oxygen will eliminate water molecule, H2O. There is a removal of hydrogen. Okay students, there is a removal of this hydrogen as well as this hydrogen. What happens students? It will form water molecules and you are getting ketone. So here the carbon oxygen, there will be double bond and CH3 will be as it is. Okay students, so this is called as ketone. Now which type of ketone students? In common name we call as acetone. We have prepared acetone from 2-propanol, or you can say this is also called as isopropyl alcohol. Acetone is also in our basic system, you can say dimethyl ketone. So this is the oxidation method. We have prepared aldehyde and dehydrogenation of alcohols. If alcohol is given students, how you are going to prepare aldehyde and ketone students? So here also students, we are going to use primary and secondary alcohols. So here students, I am going to take the example of ethanol, that is CH3, CH2 and OH. The OH is attached to this carbon. This is carbon is first degree carbon, so it is primary alcohol students. Example is ethanol. Now this is the alcohol students, that is primary alcohols I have taken. if you take the primary alcohol, students, this primary alcohol you have to mix with copper metal and heat it. You have to heat it at 573 Kelvin. Okay students, it is important students. Only one reactant is required, that is ethanol and copper, and just heat it. What happens students? There is a removal of hydrogen gas. Hydrogen gas will be eliminated. So one hydrogen from here, one hydrogen from here. So there is a removal of hydrogen students, and you are getting CS3 will be as it is, and you are getting CHO. Okay students, that is called as ethanol. So this way students, you have converted ethanol into ethanol. Very simple students, you have to add copper in ethanol and just heat it. Okay students, there is a removal of hydrogen. That is why the process name is means removal of hydrogen. It's called a dehydrogenation. There is a generation of water hydrogen gas. So that is why it is, and there is a removal. So we call as dehydrogenation of alcohols. So this way students, alcohol molecule will degenerate the hydrogen gas and it will convert into aldehyde, that is ethanol, or you can say acetaldehyde. In common name it is called as, it is containing 2 carbons, so we call as acetaldehyde. This is also, ethanol is also called acetaldehyde, and this is nothing but ethyl alcohol, or you can common name it is called as ethyl alcohol. Okay students, very simple students. So primary alcohol always gives you aldehyde, that is acetaldehyde. Understanding students? If you are taking secondary alcohol students, you have CS3, this side also you have CS3, and this carbon number 2, your hydroxyl group is attached. So that is why it is called as second degree alcohol. Which means this carbon is consists of 2 carbons, so this carbon is called as second degree, and to which your hydroxyl group is attached. That is why it is called as second degree alcohol. The name of this compound will be, in common name we call as isopropyl alcohol. This is second degree alcohol. Second degree alcohol you have to take and mix with copper. Okay students, copper metal, and you have to just heat it at 573 Kelvin. Okay students, if you don't know you are very difficult to remember, you just put this symbol in examination, it is also okay students. So isopropyl alcohol you have to heat with copper metal, and what happens students, there is a elimination of hydrogen gas. Hydrogen gas will be eliminated, and all the hydrogen gas will be eliminated. So what happens students, this carbon oxygen bond will be, there will carbon oxygen double bond, and CS3 will be as it is. Okay students, so you are getting acetone. This is acetone. So this way students, isopropyl alcohol you have converted into acetone. In examinations they may ask action of copper metal on isopropyl alcohol, so acetone you will get acetone. This is also called as, because it consists of 3 carbon, and it is called IBC name, it is also called a propanone. Okay students, so this way students you have got the ketone. So secondary alcohol, that is isopropyl alcohol, will always gives you propanone. Second raw material that we are going to use, that is called as, very important student, that is called as hydrocarbons. In hydrocarbons students, you have alkenes, you have alkene, alkyne, and aromatic. Example, benzene. Okay students, aromatic compound like benzene. So students, from hydrocarbons, so first students, raw material that is made up of hydrogen and carbon. So hydrocarbons that we are going to take here is students, that is alkene. First raw material is what? Alkene. Now the process to which we have convert alkene into aldehyde and ketone is, that is called as ozonolysis. So first reactant will be your hydrocarbon. So first hydrocarbons here we are using, that is alkene. Okay students, say for example, if you are taking alkene, means carbon and oxygen double bond, there will be carbon oxygen double bond. Okay students, now fill the valency with hydrogen. So there is 2 hydrogen, here also 2 hydrogen. Now because of ozonolysis we have to use ozone, that is O3. So what happens students, when you use the ozone gas, you have to use ozone gas in presence of solvent like chloroform, or if chloroform is not there, you can use carbon tetrachloride. This is the non-aqueous solvent students, and you have to heat at 196 Kelvin. So ozonolysis will take place students. So what happens students, this carbon and this carbon, the carbon-carbon double bond will break and it will form like this. So hydrogen, the 2 hydrogen will be as it is students. Now there is a breaking up carbon-carbon double bond, and it will convert into single bond like this. So there is a 3 oxygen, so this oxygen will be arranged like this. Okay students, so this way carbon tetravalence is completed. Now what happens students, you have to again use zinc. You have to heat it. This ethylene ozonide. This is called as ethylene ozonide. So ethene, this is your raw material ethene, which is converted when the oxygen is there, students, it will convert into ethylene ozonide. Now what happens, students, when you heat in presence of zinc and water? So there is a breaking of these two bond. Like this, students, these two bond will break. And what happens, students, when it will break, this zinc combines with oxygen, this oxygen, and it will form zinc oxide. Understanding, students, this zinc, when you heat, students, it will combine with oxygen of ethylene ozonide and form zinc oxide, and you will get two molecule of formaldehyde. This is one molecule, and there is a one molecule from here. So you are getting two molecules of formaldehyde. So this is the key aldehyde you are getting, students, formaldehyde. So students, from ethylene you have converted into formaldehyde by the process we are using ozone. So this process is called as ozonolysis of alkene. So ethene is converted into formaldehyde. From one ethene molecules you are getting two molecules of formaldehyde. Okay, students. So this is very important, students. Your yield is doubled. In second example, students, so I am taking alkene. Here propylene I am using, students, propane. Where I am using propane, students. This is propane. Propane, when combines with ozone in presence of solvent chloroform or carbon tetrachloride, and just heat it, students. So what happens, students, it will form propene ozonide. So this CH3 will be as it is. Now, students, carbon double bond will break, it will form single bond. So these three oxygen atom will combine in this fashion, students. So this way it will form propene ozonide. This is called as, there will be two hydrogen, students. So two hydrogen will be as it is. So it will form propene ozonide. Now what happens, students, when this propane ozonide, when you heat it in presence of zinc and water? So what happens, students, this zinc will combine with this oxygen and it will form zinc oxide. Now what happens, students, when we heat it, this bond will break like this. So here, students, you are getting two types of aldehyde. One is acetaldehyde. This CH3 will be as it is, and you are getting here, students, hydrogen, one hydrogen I have not written. So this is where you are getting CHO, that is aldehyde group. This is acetaldehyde, and here you are getting HCHO. Okay, students, two hydrogen, one hydrogen from here and one hydrogen here. So you are getting formaldehyde, and here you are getting acetaldehyde. This is but 2En. Okay, students, on ozonolysis, students, it will gives you in presence of solvent chloroform, and just heat it at 196 Kelvin. So what happens, students, this CH3 will be as it is. Now this double bond will break and the oxygen atom will go to attach like this. This way this oxygen atom will be attached and it will convert into single bond, students. Double bond convert into single. You are getting but 2En ozonoid. You are getting but 2En ozonide. Now this but 2 ozonide, students, when you heat it further, when you heat it, students, in presence of zinc and water, what happens, students, this zinc will combine with oxygen of this ozonide and it will form zinc oxide. So what happens, students, there is a breaking, it will break like this. So you are getting two molecule of acetaldehyde. Okay, students, you are getting two molecules, so CH3, and here you are getting CHO, and here also you are getting CH3, CHO. So you are getting two molecule of acetaldehyde. So students, but 2En will always gives you two molecules of acetaldehyde. If you are taking isobutylene, students, this is the carbon-carbon double bond. Here, students, two valency is occupied by, both the valency is occupied by methyl group. This is also methyl group. Now here, students, you have hydrogen. So total how many carbon? 4 carbons. So it is called as isobutylene, or you can say isobutene. Now what happens, students, when ozone is going to be combined in presence of solvent chloroform, or you can say carbon tetrachloride, just heat it, students, at 196 Kelvin. So it will form isobutylene ozonide. This ozone, when it will combine students, this carbon-carbon double bond will break. So this part will be as it is, twins. Only this carbon-carbon double bond will break like this. So one oxygen will combine like this, other 2 oxygen will combine like this. Okay students, so it will form isobutylene ozonide. So it will form isobutylene ozonide. Now this isobutylene ozonide, when you heat it students, in presence of zinc and water, so this zinc will combine with this oxygen and it will form zinc oxide. When it will combine with form the zinc oxide, this bond will break from both the side students, and here you are getting aldehyde as well as ketone. Here first you are getting ketone like this students. Here you are getting ketone. This is nothing but acetone. In common name dimethyl ketone, or common name you can say acetone. And here you are getting aldehyde, that is formaldehyde, or you can say methanol. In IPC system we name this compound as a methanol. So this way students, we are getting both the compound aldehyde and ketone from ethene. Next hydrocarbons that we are going to take students, that is called as alkyne. Alkyne students are carbon-carbon triple bond. Now students, carbon-carbon triple bond on hydration, that means there is addition of water molecules. We are going to add water molecules to these alkynes, so that is why it is called as hydration of alkynes. So students, by hydration of alkynes, how you are getting aldehyde and ketone, that is very important. So first example students, I am taking here students, suppose you have acetylene, carbon-carbon triple bond and other valency by hydrogen. So this is the simplest alkynes that is called as, in common name we call as acetylene, or you can say carbon-carbon, only 2 carbon is there students, that is why it is called as ethyne. It is also called as ethyne. Now students, these alkynes on hydration, when you add water molecules, this is acidic water students, this water is acidic water, it is coming from 40% sulfuric acid. To add 40% sulfuric acid, mixture of 40% sulfuric acid and 1% mercury sulfate. Okay students, so this is acidic water. What happens students, when this water will added, so this water you can also write like H and OH. Okay students, H2O. Now what happens students, carbon-carbon triple bond will break, it will form carbon-carbon double bond. Okay students, so now this carbon-carbon triple bond will convert in carbon-carbon double bond because of this acidic water students. So what happens students, this one hydrogen will go and combines here and it will have CH2, and OH will go here and it will form like this. This is vinyl alcohol. This is nothing but what? Vinyl alcohol. Vinyl alcohol students is very unstable, so because of instability to students, it will go tautomerism. On tautomerization, the tautomerization will take place students. That means here students, because of this, the double bond will go and combines with oxygen carbon, there will be double bond. This one bond will migrate here, so students, and one hydrogen will migrate from here, so it will form CH3 and it will form CHO. So this way students, you are getting acetaldehyde. You are getting acetaldehyde as a aldehyde. So this is acetaldehyde. So this way students, we have got acetaldehyde from ethyne, or you can say acetylene. How acetylene is converted on hydration, it will form acetaldehyde. So this way students, you have to write in board examination. So hydration of alkanes is nothing but addition of acidic water molecules to acetylene, and you are getting acetaldehyde. Now second example students, second alkyne that we are going to use, that is called as propyne. So here students, carbon-carbon triple bond, and this valency is occupied by methyl, so it is called as propyne. This is the alkyne students. We are adding water molecule. Since it is acidic water, so it is like this. You have to represent how acidic water is coming students. For that you have to use 40% sulfuric acid. You have to mix with 1% mercuric sulfate. So you are getting acidic water students. This is negative students, and this will be positive. Okay students, now what happens students, the carbon-carbon triple bond will break, it will form carbon-carbon double bond. This CH3 will be as it is, and what happens students, this hydrogen will come to the hydrogen where the second hydrogen is there. This positive part of hydrogen will combine, it will form CH2. It will go here students, and this hydroxyl will be attached like this. Understand, negative part will go that carbon not having any hydrogen. This is very important students. So this way you have to keep in mind students, this hydroxyl will go to this carbon not having any hydrogen. Understanding students? Now what happens, students? This is unstable, students. On tautomerism, students, it will form tautomerization. On tautomerization, students, what happens? This bond will come here and this hydrogen will go here. So it will form carbon oxygen double bond, and there is a CH3, and this CH3 will be as it is, students. So this way, students, there is a formation of ketone that is called as acetone, or you can also say it is made of 2-methyl, so dimethyl ketone. This way, students, we have got the dimethyl ketone from propylene. Understanding, students? So there is a formation of dimethyl ketone containing 3 carbon, from 3 carbon propyne to 3 carbon dimethyl ketone. So this way, students, alkyne is converted into what? Ketone, that is acetone. So propane we have converted into acetone by oxidation of aromatic hydrocarbons. So far we have taken aliphatic hydrocarbons. Now here we are going to use aromatic hydrocarbon systems. We are going to oxidize aromatic hydrocarbons, and we are getting aldehyde or ketone, that is we are going to see here. First example, students, here we are going to oxidize aromatic hydrocarbons. The first aromatic hydrocarbons here we are going to use, students, here, students, that is toluene. Aromatic hydrocarbons may be benzene, maybe toluene. Okay, students. Now what happens, students, if toluene, students, oxidation of toluene if you are taking. So toluene, students, this is the structure. Toluene is consists of benzene ring as well as methyl. It is made up of methyl, CH3. So this is the structure of toluene, students. In common name we call as toluene. Okay, students, or since it is methyl group and this is benzene, sometimes we call as methyl benzene, or you also call as what? Methyl benzene. Okay, students. So on we are going to use the oxidizing agent as a chromyl chloride. Formula of chromyl chloride, chromyl, and this is chlorine, so we call as chloride. So name is, so your raw material is toluene, that is hydrocarbons. If you add this oxidizing agent as a chromyl chloride in presence of carbon disulfide, heat it, what happens, students? There is addition of this chromyl chloride complex. It will form the toluene and chromyl chloride complex. So what happens, students? It will form the complex like this. So students, two molecule will combine like this. Oxygen is 2, so this oxygen of chromyl chloride will combine and it will form the, and one hydrogen is there, students. So chromium will be as it is and will form the hydroxyl group, and there is a 2 chlorine. Okay, students. So this way, students, it will combine. Now this hydrogen will combine with this oxygen, one oxygen will combine like this, and it will form CrOH twice and Cl2. This is chromium complex because it is containing chromium. This chromium complex, students, when you add acidic water, students, CH3, what happens, students? It will gives you, this bond will come here and it will form aldehyde group like this, C double bond H. So students, we have this methyl is converted into aldehyde group. Okay, students. So this is also called as, and we have converted into benzaldehyde, which is very important. This is aromatic aldehyde, students. So from aromatic hydrocarbons we have converted aromatic aldehyde. So toluene, the methyl of the toluene is converted into aldehyde group. So this was discovered by scientist Itard. That is why it is also called as Itard reaction. In board examination, sometimes they are asking what is Itard reaction. Itard reaction, students, this reaction is called as Itard reaction. So student, toluene combines with chromyl chloride and it will give you benzaldehyde. So this type of reaction is called as Itard. This was discovered by scientist Itard. That is why it is called as Itard reaction. So here, students, this methyl of toluene is converted into aldehyde, which is very important. That is why this reaction is very famous. That is called as Itard reaction. We are going to convert aromatic hydrocarbons here. Again, I am taking, students, toluene. This is benzene along with second hydrocarbon, that is aliphatic hydrocarbons, that is methyl, students, methyl and benzene. So this complex, sometimes it is called as methyl benzene. In common name we call as toluene, or you can also say methyl benzene. Methyl benzene is nothing but toluene. And this is the all aromatic hydrocarbon, students. If you use chromium oxide, if you are using chromium oxide, students, if you use chromium oxide, if you want to oxidize toluene with the help of chromium oxide, this is the formula, students, CrO3, chromium oxide, and acetic anhydride with acetic anhydride. So what happens students, when we heat it, here this will combine here students with toluene, and it will form complex like this students. This hydrogen I am writing like this. Now what happens students, this will combine with here, and it will OCH3. Here 2 molecule of acetate will combine like this students. There is a 2 molecule of acetate. So what happens students, it is diacetate derivative, which is unstable students. It will break like this and you will get benzaldehyde. This way students, we have converted toluene, methyl benzene, you have converted. Okay students, so this way students, in board examination sometimes they may ask action of acetic anhydride. This is acetic anhydride plus chromium oxide. This is called as acetic anhydride. This mixture students you have to add in toluene and you will get benzaldehyde. So here the toluene is again converted into benzaldehyde, but the second reactant is students, it is a mixture of acetic anhydride and chromium oxide students. So this acetic anhydride will form the complex that is called as diacetate complex derivative, and this is unstable, so it will lose this molecule and it will form benzaldehyde. So this way students, we have converted toluene into benzaldehyde. This is very important oxidation of aromatic aldehyde. Now one more example students, we are going to see. Third reaction students, toluene is given. What happens students, when you pass these hydrocarbons, if you do the chlorination students in presence of UV light, pass the chlorine gas to this toluene students, there is a formation of, it's called as benzyl chloride. Now what happens students, if you pass acidic water and just heat it students, it will give you benzaldehyde. In examination sometimes they ask action of chlorine on toluene or methyl benzene. So this also you get aromatic aldehyde. So aromatic hydrocarbons you have converted into aromatic aldehyde. So conversion of aromatic hydrocarbons into aromatic aldehyde. So this in examination, this way they may ask in board examination chlorination of toluene. So this way students you have to represent the answer. Very important. Mind well, you have to see this methyl is going to convert into aldehyde group. So that is why this reaction is very important. One more example that we are going to see here students. Aromatic students hydrocarbons here, instead of that I am taking only the benzene. Now students, how this aromatic compound we are going to convert into aldehyde? If you are using carbon monoxide gas, HCl, and anhydrous aluminum trichloride students. So there is a formation of aldehyde group. This mixture will form, this benzene will be as it is students. There is a formation of aldehyde group here. There is a formation of new aldehyde group that is called as benzaldehyde. So students, benzene you have directly converted, benzene without any substituent students, it is converted into benzaldehyde. So this is very important students. This was discovered by scientist Gutterman-Koch. This Gutterman-Koch, that is why it is called as Gutterman-Koch reaction. This is also called as Gutterman-Koch reaction. Understanding? So only benzene you have converted to benzaldehyde. Okay students, this is called as Gutterman-Koch reaction of hydrocarbons benzene. So the conversion of benzene into benzaldehyde using carbon monoxide, HCl, and anhydrous aluminum trichloride. If you heat this mixture students, you will get at high pressure. You have to use high pressure. At high pressure you will get benzaldehyde. So this way students, aromatic hydrocarbons we have converted into aromatic aldehyde. So from benzene you have converted to benzaldehyde. This was discovered by Gutterman-Koch. So that is why this reaction is called as Gutterman-Koch reaction. In examination sometimes they may ask what is Gutterman-Koch reaction. So you have to remember this part students, carbon monoxide, HCl, anhydrous aluminum trichloride. If it is not there students, you can also use cuprous chloride. Instead of that you can use cuprous chloride. So this way students, we have converted benzene into benzaldehyde. Sixth type students, you have benzene. This is aromatic hydrocarbon students. Benzene is aromatic hydrocarbons. If you add acetyl chloride, CH3, CO, and here also chlorine. So this is acetyl chloride students. This is acetyl chloride. carbonyl 2 valency, 1 valency by chlorine, other by methyl. Okay students, so this is called as acetyl chloride. Action of acetyl chloride on benzene. First, this chlorine, which is very reactive, this chlorine will combine hydrogen which are present here and it will form HCl. Okay students, now this carbon of the carbonyl now combines with this carbon and there is a formation of COCH3. COCH3, this is nothing but acetophenone. There is a formation of acetophenone, which is ketone students. This is aromatic ketone students. So this way students, benzene, aromatic hydrocarbons we have converted into ketone, that is acetophenone. So this is very important students. So action of acetyl chloride will always give you ketone, that is example I have given, that is acetophenone. Here you have to use anhydrous aluminum trichloride you have to use and you have to heat it. Then only these two reactant combines and they will form acetophenone, that is ketone. One more example students, you have benzene students. If you have benzene, if you add acetic anhydride CH3CO, oxygen 2 valency. So this is acetic anhydride students. Action of acetic anhydride. This is the example students, benzene combines with acetic anhydride in presence of anhydrous aluminum trichloride and just heat it. What happens students? One of COH3, here the hydrogen will combine with this and it will form CH3COOH. Now one of the acetyl group will combine with this benzene like this. Again students, you are getting acetophenone, that is ketone. So this way students, you have got the ketone. This way you have got the ketone from benzene. Action in examinations they may ask action of acetic anhydride on benzene. So there is a formation of ketone. So action of acetic anhydride on benzene will always gives you ketone, that is acetophenone. Third example students, you have benzene. This is aromatic hydrocarbon. Benzene is aromatic hydrocarbons. Action of benzyl chloride C6H5. One of the hydrogen of this benzene I am replacing with CO. Okay students, so carbonyl 2 valency, 1 valency by benzene, other is chlorine. So this is called as benzyl chloride. This is called as benzyl chloride. So action of benzyl chloride on benzene in presence of anhydrous aluminum trichloride and just heat it. What happens students? This chlorine of benzyl chloride will combines with hydrogen. It will combines with hydrogen of this benzene and it will form HCl. And this carbon of the carbonyl will combines and it will form COC6H5 like this. That is called as diphenyl. This is phenyl, this is also phenyl. So it is diphenyl ketone. So students, this way we have prepared aldehyde and ketone from hydrocarbons. Third material from acyl chloride, that is also called as acid chloride. That means here the chlorine will be there with acyl group. Carbon oxygen group we called as acyl and here it is chlorine. So we called as acyl chloride, or you can say acid chloride. Chloride which is acidic, that is why it is also called as acid chloride. Acetyl chloride here students I am taking is reduced to acetaldehyde, that is aldehyde students. Acetyl chloride is reduced to acetaldehyde by hydrogen in presence of palladium catalyst, PD catalyst, poisoned with barium sulfate. You have to use barium sulfate also. So it is a mixture of palladium and barium sulfate which will provide hydrogen, and because of this hydrogen acetyl chloride is reduced to acetaldehyde. And this was discovered by the scientist Rosenmund. That is why this reaction is very famous in the name of Rosenmund, that is called as Rosenmund reaction. Who had prepared this aldehyde? So preparation of aldehyde from acetyl chloride by using palladium catalyst and barium sulfate is called as Rosenmund reduction. So acetyl chloride is reduced to aldehyde. That was discovered by the scientist Rosenmund. So the reaction is called as Rosenmund reaction. So here students, I am taking the simple example of acetyl chloride. That is, this is carbonyl 2 valency, 1 valency by methyl. So it is called as acetyl, and this is chloride. So this is acetyl chloride students. This acetyl chloride is reduced by passing hydrogen gas. This is hydrogen gas students. When you pass this hydrogen gas, this molecule will accept hydrogen gas and it is reduced. That means acetyl chloride will reduced by accepting hydrogen and giving out chloride. So this hydrogen is coming, students, in presence. It is a mixture of palladium and barium sulfate. So this catalyst is very important, students. You have to write it down. So this will provide hydrogen gas, and this acetyl chloride will accepting hydrogen is called as reduction. So what happens, students? There's a elimination of HCl. Out of 2 hydrogen, 1 hydrogen will combines with this chlorine and it will gives you HCl. And what happens, students? This carbonyl, now this group is occupied by hydrogen and your CH3 will be as it is. So there is a formation of acetaldehyde, that is called as aldehyde. Which type of acetaldehyde? So here we have converted acetyl chloride into acetaldehyde. This reaction is called as Rosenmund reduction. Here it is which type of aldehyde? This is aliphatic aldehyde. Suppose you want to prepare aromatic aldehyde. For that, students, you have to take benzyl chloride. If you want to prepare aromatic aldehyde, you have to take, this is benzyl chloride. Okay, students, instead of acetyl, this whole group is called as benzyl. When you pass the hydrogen gas, this hydrogen gas, students, it will generate the hydrogen gas when it is a mixture of barium and palladium metals. Okay, students, in presence of this catalyst, this hydrogen gas will react this chlorine and it will form HCl, and one of the hydrogen now it will attach to this carbon of the carbonyl and it is forming aldehyde. So this way, students, you can get benzaldehyde. This is nothing but benzaldehyde. This way, students, we have prepared aromatic and aliphatic aldehyde using Rosenmund reaction. This is also called as what? Rosenmund reaction. From acetyl chloride also you can prepare ketones. Now here ketones are obtained from acyl chloride by reaction with dialkyl cadmium. So students, if you have acyl chloride, if you react with dialkyl cadmium, it will gives you ketone. Okay, students, so your raw material is here. Again I am using acetyl chloride, carbonyl, one valency by chlorine, other by methyl group. So this is acetyl chloride. When react with dialkyl, instead of dialkyl I am taking dimethyl cadmium. So here, students, CH3, there is a 2 methyl group, so we call as dimethyl, and this is your cadmium. Cadmium is having cadmium 2+, so it is required 2 methyl group. So this is the acetyl, and this is what? Chlorine, so we call as acetyl chloride. This your raw material is acetyl chloride. This acetyl chloride react with dimethyl cadmium. So what happens, students, when you heat it, you will find, because there is a 2 methyl atom is there, students, so these 2 methyl will require 2 acyl groups, so you have to write 2 molecule. Now here it is 2 molecule of acetyl chloride will react with 1 molecule of dimethyl cadmium, and it will gives you 2 molecule of acetone. So this way, students, you have got the acetone. This is acetone, common name is acetone, and IUPAC name will be propanone. Why propanone? There is a 3 carbon containing carbonyl group we call as propanone. Okay, students, you can say acetone or propanone. Both are ketone, students. So acetone and propanone are the same. So this way, students, we have prepared aliphatic ketone by using dimethyl cadmium, and here, students, you are getting cadmium dichloride as your byproduct. So this way, students, we have got the ketones. So ketones are obtained from acyl chloride by reaction with dialkyl cadmium. So this is dimethyl cadmium. Instead of dialkyl, you can take any alkyl group, students. So here I have taken methyl, so it is called as dimethyl cadmium. React with acetyl chloride and it will gives you ketone, that is acetone and propane. In examination they may ask the action of dimethyl cadmium on acetyl chloride. So this way, students, you have to write down the reaction, you will get the full marks. Now if you want to prepare, this is aliphatic ketone, students. If you want to prepare aromatic ketones, for that, students, your raw material, instead of acetyl chloride, you have to take benzyl chloride. If you want to prepare aromatic ketones, so you have to take benzyl chloride, C6H5. Then this benzene is attached to carbonyl of this carbon, and one is chloride. So this is called as benzyl chloride. This is benzyl chloride. When this benzyl chloride react with dimethyl cadmium, this is 2 methyl group which is attached to cadmium atom, so we call as dimethyl cadmium, and just heat it, students. What happens? There is a formation of this carbonyl group, students. This chlorine now react with cadmium and it will gives you cadmium dichloride. Okay, students, because there is 2 methyl groups, so you have to make it twice. So 2 molecule of benzyl chloride react with 1 molecule of dimethyl cadmium and gives you cadmium chloride, and this methyl, students, will attach like this, and your C6H5 will be as it is. Since there is a 2 methyl group, so you have to make it twice. So this way students you have to balance the reaction. So this way students you can show this is the formation of aromatic ketone. What is the name of this ketone students? Instead of here phenyl group is attached, so it is called as acetophenone. This is aceto and it is phenol, so it is called as acetophenone. Acetophenone is aromatic ketone students. Very important. This way students we have prepared the aromatic ketones also. Now students, when acetyl chloride is treated with benzene in presence of anhydrous aluminum chloride, acetophenone is obtained, is known as Friedel-Crafts reaction. Okay students. Now students, here the acetyl chloride is treated with benzene in presence of, now here students we are using anhydrous aluminum chloride in presence of, this is the catalyst students. So acetyl chloride is treated with benzene. So students, here the acetyl chloride, again I am taking carbonyl, 2 valency, one valency by chlorine, other by methyl. So this is your raw material students from acetyl chloride, how you are getting acetophenone, that is ketone. So students, when acetyl chloride is treated with benzene in presence of anhydrous aluminum chloride, so this is your acetyl chloride when treated with benzene, react with benzene students in presence of anhydrous aluminum trichloride, and you have to heat it, these two reactant. What happens students? There is a formation, this chlorine will react with this hydrogen of this benzene and it will give you HCl. Okay students. Now what happens students? It will form the product. First I am writing benzene, and this bond will, carbon of this carbonyl now will attach to this carbon of this benzene, and it will give you acetophenone. This is also aromatic ketone students. We have prepared aromatic ketone, that is acetophenone. But here students we have used aluminum trichloride and benzene, and this reaction was discovered by Friedel-Crafts, so it is also called as Friedel-Crafts acylation. The reaction is also called as what? Friedel-Crafts acylation. In examination sometimes they may ask prepare acetophenone by using Friedel-Crafts reaction, so you have to use these two reactant, acetyl chloride and you have to use benzene. Acetyl chloride and will react with benzene in presence of aluminum trichloride and heat it, you will get acetophenone. The formation of acetophenone by using acetyl chloride and benzene is called as Friedel-Crafts acylation. Fourth raw material from where we are going to get aldehyde and ketone is nitriles. Nitrile is also called as cyanide, where carbon is bonded with nitrogen, with triple bond with nitrogen. So this is called as nitriles. This is also called as cyanide or nitriles. Nitriles are reduced to imine hydrochloride. How students we are going to reduce the nitriles? When nitriles are reduced to imine hydrochloride by using stannous chloride, this is SnCl2, that is stannous chloride, in presence of HCl gas, and what happens students? It will form imine hydrochloride. There is a formation of imine hydrochloride. When you pass stannous chloride to nitriles, there is a formation of imine hydrochloride. This imine hydrochloride on acid hydrolysis students gives you aldehyde. This was discovered by the scientist Stephen, that is why it is called as Stephen reaction. Okay students, in examination sometimes they may ask what is the Stephen reaction. So students, there is a reduction of nitriles by using stannous chloride in presence of HCl gas is called as Stephen reaction. First I am taking in general reaction nitriles. I am taking any nitriles. Suppose this is the alkyl of this carbon, this is called as nitriles. And which type of nitrile I have attached with alkyl, so it is called as alkyl nitrile. It is called as what? Alkyl. Instead of alkyl you can take aromatic, that is called as aryl nitrile. So I am taking aliphatic, that is alkyl nitrile. Alkyl nitrite, it is also called as nitriles or nitrite. When it is react with alkyl, now it is called as alkyl nitrite. When this alkyl nitrile is reduced with nascent hydrogen, from where this nascent hydrogen is coming students, it is a mixture of stannous chloride in HCl, in dilute HCl students, it will provide nascent hydrogen. This nascent hydrogen will reduce. Now here students, alkyl nitrite will accepting hydrogen is called as reduction. So this alkyl nitrite will reduce to aldehyde. So that is why it is called as what? First it will form the intermediate students. First it will form the intermediate, that is called as imine hydrochloride. So here students, carbon nitrogen triple bond is there. So first carbon nitrogen triple bond will convert into carbon nitrogen double bond. Okay students, now one of the hydrogen will come here like this, and one of the hydrogen will come here, and because of HCl is there students, so it will join like this HCl. So it is called as imine hydrochloride. So this is the unstable product students. This is imine hydrochloride. Imine hydrochloride. Now on acidic hydrolysis students, you have to pour acidic water. So what happens students? There is a formation of ammonium chloride. There is nitrogen and 4 hydrogen, so it will form NH4Cl, and you are getting this alkyl will be as it is, and you are getting carbon, hydrogen, oxygen. So there is a formation of this aldehyde, aromatic aldehyde. This is called as Stephen reaction. Okay, students. So along with ammonium chloride, there is this aromatic aldehyde is formed. This is called as Stephen reaction. So alkyl nitrite is reduced to aliphatic aldehyde. The reaction is called as Stephen reaction. Here there is reduction of alkyl nitrite to alkyl aldehyde, that is alkenal. This is also called as alkenal, that is aldehyde, aromatic aldehyde is called as Stephen reaction. Ethane nitrile students when react with nascent hydrogen, which is coming stainless chloride. So this carbon nitrogen triple bond will convert into carbon nitrogen double bond. One hydrogen will come here, and one hydrogen out of two hydrogen, one hydrogen will come this side, and it will form the imine hydrogen chloride. Because of this, the name this imine hydrochloride will be acetaldehyde. This on acidic hydrolysis students, it will gives you CH3 CH, and instead of here students, this is carbon, hydrogen, and oxygen will form the bond, and there is elimination of NH4Cl. There is a formation of acetaldehyde. So ethane nitrile is converted by reduction with stainless chloride and dilute HCl. It will give you acetaldehyde. It is also called as Stephen reaction. So ethane nitrile is converted into acetaldehyde using stainless chloride and dilute HCl. It will reduce the reduction of this ethane nitride to acetaldehyde is called as Stephen reaction. Now students, you can also prepare aromatic aldehyde. For that students, you have to take the aromatic nitriles. Here the aromatic nitrile I am using benzene, which is attached to carbon of this cyanide. So this is called as benzonitrile. Benzene is attached to carbon of this cyanide, so it is called as benzonitrile. This benzonitrile on reduction with hydrogen, this hydrogen is coming, it is a mixture of stainless chloride and HCl, which will gives you nascent hydrogen. So what happens students, first this carbon and nitrogen triple bond will convert into carbon-carbon double bond, because one of the hydrogen will combine here and one of the hydrogen, and your benzene will be as it is. Okay students, now HCl vapor will also attach to this benzene, attached to this imine, so it is called as, so this benzoimine hydrochloride now on acidic hydrolysis, it will gives you. So here students, this carbon hydrogen and there is a carbon oxygen bond will be there, so I have written CH group. So this is called as benzaldehyde. So there is aromatic aldehyde students, benzaldehyde is aromatic, and there is elimination of ammonium chloride. So this way students, we have prepared the aromatic aldehyde from benzonitrile. So benzonitrile is converted into benzaldehyde using stainless chloride. This is also called a Stephen reaction. So this way we have reduced benzonitrile into benzaldehyde. Ketones are prepared by reacting nitriles with Grignard reagent in dry ether as a solvent by acidic hydrolysis. You can also form the ketones. Ketones are prepared by reacting nitriles with Grignard reagent using Grignard reagent. In examination sometimes they will ask action of Grignard on ketones. Action of Grignard reagent on nitriles. Action of Grignard reagent on nitriles gives you ketones in presence of dry ether known as acidic hydrolysis. Methyl cyanide when react with Grignard reagent, that is methyl magnesium iodide in presence of dry ether. So what happens when carbon nitrogen double bond will becomes carbon nitrogen triple bond will becomes carbon nitrogen double bond. Okay students, so this methyl group will be as it is. So what happens students, here this methyl now it will go to this carbon. Okay students, and this magnesium iodide will attach like this, magnesium and iodine. This is unstable product students. What happens students on acidic hydrolysis? So here the bond will break students on acidic hydrolysis. When you add OH, what happens students? There is a carbon now react with oxygen. Okay students, so it will form acetone. acetone, and you are getting magnesium hydroxyiodide as a byproduct, students. So this way, students, we have prepared the ketone. So here, students, ketones are also prepared by reacting nitriles. This is the nitrile, students, methyl cyanide. This is the Grignard reagent. So reacting with nitriles with Grignard reagent, dry ether as a solvent, on acidic hydrolysis, it will give you ketone. So ketones are also prepared by reacting nitriles with Grignard reagent. With the help of the Grignard reagent, you can also convert this methyl cyanide into acetone. Okay, students, in examination, sometimes they may ask action of Grignard reagent on methyl cyanide, which product you will get? You will get acetone, or it is also called as propanone. So suppose, students, you are taking second example also. Instead of methyl cyanide, I am taking benzonitrile, that is, when react with Grignard reagent, students, here the instead of methyl, if benzene is attached, we call as phenyl magnesium bromide, which is attached to magnesium and bromine. So it is the phenyl magnesium bromide in presence of dry ether. The reaction is carried out in dry ether, students. So what happens, students? This carbon nitrogen double bond will become carbon nitrogen single bond, triple bond will become carbon nitrogen. Okay, students. So this phenyl will go and attach to this carbon. So this way I am writing, students, and it is attached to magnesium and bromine. Since it is unstable, students, if you add acidic water, so it will gives you here, students, instead of nitrogen, now oxygen will take the place, and there is a formation of benzophenone, which is aromatic ketone, students, and there is a elimination of magnesium hydroxide and bromide. So this way, students, there is a formation of aromatic ketones. Which type of ketone? Benzophenone is formed from benzonitrile. Only aldehydes are prepared during the aliphatic and aromatic ester reduction using diisobutyl aluminum hydride, we call as D-bi-hydride, D-bi-H. It is also called as D-bi-H. Yeah, aluminum hydrogen diisobutyl. So diisobutyl aluminum hydride. So this is the formula, students. Diisobutyl. Here it is 2. So we are writing diisobutyl aluminum hydride. So this way, students, we are writing you can say D-bi. Action of D-bi on ester will always give you only aldehyde. Example, students, you can take ester 2 valency, students. Carbonyl is 2 valency, other valency by ethoxy group C2H5, and other valency by ethyl C2H5. Okay, students, 2 valency of carbonyl, 1 valency by ethyl, other by ethoxy. So it is called as, this is ester, students, ethyl propionate. When react on reduction, students, using D-bi-H, that is diisobutyl aluminum as a catalyst, or you can say aluminum diisobutyl aluminum hydride, or you can say D-bi-hydride. So what happens, students? Here one of hydrogen will go here and will form ethanol. It is the formation of ethanol and propanaldehyde. So this way, students, we have prepared only aldehydes are prepared from ester. If you have ester, students, if you reduced only aldehyde, you will get. So this way, students, we have prepared the aldehyde and ketones from these all 5 raw materials. These are very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.